Welcome to this episode of the Structural Engineering Channel, a podcast focused on helping structural engineering professionals stay up to date on technical trends in the field and to help them succeed in their careers and lives. In this episode, we'll be talking with Tanya Luthi, a structural engineer and vice president at Entuitive, a multidisciplinary engineering practice operating in multiple offices across North America, about some of the unique aspects of designing with mass timber and what she thinks makes a successful timber engineer. I'm your co-host, Matt Picardle.
And I'm your co-host, Rachel Holland. Now let's jump into our conversation of the week with Tanya.
This episode of the Structural Engineering Channel is brought to you by PPI, a leader in engineering exam prep for the PE structural exam. PPI provides expert prep courses and study resources designed to help you pass the PE structural exam the first time. PPI's PE structural course is fully updated and taught with October 2021 code references and includes new editions of their PE structural books. PPI's live online courses include hours of lectures, problem-solving demonstrations, exam strategy sessions, office hours, and a passing guarantee. When you take a live online course, PPI guarantees you will pass, or you can take the on-demand course for free. PPI has helped engineers achieve their licensing goals since 1975. Check out PPI today at PPI2pass.com to see all of the resources available for PE structural exam prep. Again, that's PPI2pass.com.
Hi, Tanya. Welcome to the show. Thank you so much for being here. Can you please tell us a little bit about yourself and also provide background on your career journey up to this point?
Sure. Thanks so much for having me on. I really appreciate it. So I am a structural engineer. My career in engineering started almost exactly 20 years ago. I went back to school, actually. I got my undergraduate degree in political science, of all things, and worked for a little while before eventually figuring out that I wanted to be an engineer when I grew up. So I went back to school. I went to the University of Texas at Austin, caught up on a whole bunch of undergraduate work, and then got a master's degree in structural engineering. So after studies, then I started my career in New York City, and I did mostly large-scale institutional projects, universities, museums, really cool and rewarding stuff. Did that for about 5 years, and I reached a point where I thought to myself, I really love it here, but if I don't leave now, I'm going to spend my whole career at this one firm. And as much as I love it here, I feel like I should get out and see something else. I think that would be good for me. So I kind of threw a dart at the map and decided to move out west. I moved to Vancouver and found a job out there in British Columbia. And it just so happened that I worked for a firm that is very well known for doing mass timber buildings. And so I essentially got hooked after doing my first timber building. I had no experience whatsoever in timber before that. I didn't study it in school. I had never done any projects. If you had asked me, I usually joke that I would have told you back then that nobody builds real buildings out of wood. So obviously I don't think that anymore. So I spent about 5 years out in Vancouver. And then when I came back to New York, because this is home for me, so I grew up around here, I kept the focus on timber. And so the further I go in my career, the more focused I become, because I just really enjoy designing in mass timber and the kind of world that it has introduced me to. So besides the work that I do as a designer, I also have gotten involved in things like building codes, code committees, and I've had the great honor the last couple of years to serve on the board of directors of Woodworks, which is a nonprofit organization that helps support multifamily and institutional commercial wood projects across the whole country. So yeah, it's been a really interesting journey so far. Can't wait to see where the rest of it goes.
Yeah, I think that was really interesting because you said I think a lot of structural engineers when they're students, they don't take timber class. It's not like steel or concrete where everyone takes
Right.
it. And yeah, you kind of had to learn it on your own. Could you, from your perspective, it seems like you fell in love with it. From your perspective, can you tell us more about why you enjoy or I guess what got you hooked with mass timber, and maybe some of the unique aspects of designing with it, and I guess maybe uh, how you learned as well when you said, "Oh, I've never even taken a wood class." Could you go into that a little more?
Sure. Well, like I said, I had the really good fortune of being surrounded by a lot of really experienced people. So even though I didn't really have kind of that first principles basis from school, I was able to really learn a lot from the people that were around me that were very experienced. So that was a big part of it. And it definitely is from starting in the world of steel and concrete and trying to adjust to a bunch of things that are really different when you design in mass timber. So for one thing, it's a natural material, so it's just inherently very variable. So when you design in steel or concrete, you can just put in your specifications, certain grades that are very standardized, right? If it's a steel, it's got a very specific chemical composition and yield strength, and sort of all these things that you can make very uniform because these are sort of human-made products. And with mass timber, it's never going to be like that because it's like I said, it's a natural material, different species, different climates. All these things contribute to a lot of variability in the material. So it's more complex in terms of understanding the safety factors that are built into things and the values that we use when we design of different types of strength. And then of course for wood there's also directionality to it, right? Wood is strong and stiff parallel to grain, and much weaker and less stiff perpendicular to grain. So that's also something you're not really used to when you design in steel and concrete. So the other interesting part about it is that it's not, mass timber products are not commodity products, so they're not all the same. Every manufacturer sort of makes their own specific, layups and sizes, and they have their own sort of idiosyncrasies in terms of how they fabricate things. And really understanding that is important in the design of these kinds of structures. It's a combustible material, right? So you're not used to that in steel and concrete. You sort of pay relatively little attention to fire design as a structural engineer in steel and concrete. You sort of have this vague idea that there's a UL listing somewhere out there that you have to match so that you get your fire rating. But really kind of understanding fire engineering, even if you're not a fire engineer, you need sort of a basic understanding of what that is and what it's about so that you can design properly large scale mass timber buildings. It's also a material that absorbs and releases moisture from the atmosphere. So then, in addition to learning from your fire engineering colleagues, you're also needing to learn a lot from your building envelope and building physics colleagues about how this material behaves with moisture changes. And all these things make it sound like it's complicated, and it is, but it's also what's really nice about it, I think, is how sustainable it is. Understanding embodied carbon, which our profession is really starting to pay more attention to, the energy that goes into creating the things that we put into buildings, and not just the energy that the buildings consume when they're occupied and being heated and cooled and all of that. So again, it sort of ropes you into this world of forestry even a little bit. So again, you don't need to be a forester, but kind of that basic understanding of sustainable forestry, how we grow and harvest the trees that go into these products. So it really is unique. I think it's just easier to get sort of pulled into all kinds of different areas and not just the narrow lane that often we stay in as structural engineers of sort of sizing beams and columns and doing that kind of stuff.
That was great. I think it was really interesting to see that it's not just like you said, it's not just designing the timber or the wood. It really branches out into a lot of these other things that are becoming more and more important in our industry, like sustainability and the world that opens up with, I'm sure, with connections, different types of connections. Everyone's trying to figure that out, and there's a lot to learn, it seems like.
Yeah, and it's changing so fast, and I really like change. I get bored very easily, so I think the fact that you have to be on your toes, you always have to be learning new things. For me, that's really fun. I think it keeps you from getting in a rut. So
definitely makes it more exciting.
I think so.
You touched on quite a few of this, or quite a few aspects of this already, but just in terms of actual like design for how does the process when you're doing a mass timber design, how does that differ from when you're doing something, more traditional made of steel or concrete?
Yeah. Well, one of the big changes is, or the big differences is that when in an ideal world, designing a mass timber building, a lot of the decisions that you need to make ideally will come much earlier in the process. And they should be, the decisions often need to be made in a little bit of a different way. So what I mean by that, again, going back to what I said earlier about, well, these are not commodity products, right? Every manufacturer makes a slightly different set of elements. And so on a lot of mass timber projects, getting a fabricator involved early on can be really very helpful in trying to optimize your design for that particular supplier's lineup, if you will. And on every project, that's not always possible, depending on how the project is set up. But even when you don't do that, the sort of understanding what the implications are of if you wind up with supplier X versus supplier Y versus supplier Z, and trying to sort of build that into your design is important. I think, we mentioned already a little bit about connection design. That's a huge part of it. And in steel and concrete, you often don't think about that until the very end, if you think about it at all, right? And a lot of, not so much in high seismic zones like California, but when you design, say, a steel building on the East Coast, it's very, very common that you don't design the connections at all. You put some forces on the drawing and ship it off, and the steel fabricator decides how they want to do it. But in a mass timber building, it's really sometimes like figuring out the connections, and it's the connections that really are going to drive the design, like making sure, I mean, it sounds basic, but do you have enough room to fit all the fasteners that you need to make a beam column connection? And if it needs to be inside, completely encased in the timber for fire protection, just really making sure that you've thought through. So you have to kind of zoom into that detail level a lot sooner than you would on a steel or concrete building, where you're just less likely to have challenges with that. And then I think, like I said, just understanding the different capacities of different suppliers. And if they're on board, that's great, because it means you can collaborate very closely right from the get-go. And that often, especially on a large, complicated project, can really be an advantage, and is often the way to go. But, on smaller projects and on certain types of projects where, the owner wants to still do a more traditional design bid build process, you can still do that. Again, it's just a little bit more tricky than it might be in a steel or concrete building.
And you mentioned different types of aspects with timber design, different from concrete and steel. It seems like there's a lot of things to take into account. In your opinion, what makes a successful timber engineer? I think you mentioned some of them, but I guess in your opinion, maybe when you're training someone new, what makes them stand out as a good timber engineer versus maybe just a typical concrete or steel engineer?
I think a really solid foundation in the first principles of the material behavior. I think that's true no matter what material you're designing in. That's true for steel and concrete too. But I would say for timber, it's even more important, because there's not such a huge body of precedent projects that you can look to try to get some of your questions answered. So you really have to often think with a blank slate about what is going to make sense. You can't just sort of steal a detail from someone else's project or another project at your firm or all these things. You have to really, I think you have to really love continuing to learn, because there's so much to learn. I mean, I've been doing it for a decade and I don't know half the things I think I really need to know. So it's always a process of learning. And like I said, because I didn't study it in school, you wind up sort of doing a lot of going down rabbit holes, and I mean that in a good way, but really kind of researching and understanding how the material behaves and how it fails when it does, and what are the ways that we can counteract that. And then also thinking like a fabricator. So actually, some of my favorite projects that I've worked on as not as the engineer of record, but as a specialty engineer working for a fabricator. So if the project does have, say, delegated timber connection design, of working for the fabricator to do those designs, and it really gives you insight into how things are made, And it's that knowledge that makes you a better designer. So I would say if you ever have the opportunity to work for a fabricator, that's amazing experience. It's also really fun. And you get to see, the design process often takes many, many years. When you work for a fabricator, the nice thing is, you're pretty much already about to start construction. So you get on site really fast, which is fun as well. And I think just being open and collaborative and sharing what you know. It's not the mass timber world, especially right now in North America. It's not that big of a world. So, you'll come across a lot of folks. And one of the things I've liked about it is that it's a very kind of open community of people I've found, willing to share what they know. And like I said, because you're always learning new things. So, just being part of that open, collaborative community is really important.
That's definitely one of my favorite things. It's like just all these great minds coming together because they want to just build that material and its ability to be used here, right? So that's great. What about you touched on this earlier too, talking about like the energy, we're starting to think beyond just what the building is going to use currently, but can you talk about sort of the link between mass timber and sustainability?
Yeah, so sustainability certainly is something that it's almost become a buzzword, like used so much that sometimes you have to be careful what you mean when you talk about it. But to me, on the structure side, when we first started, we as a design industry started thinking about sustainability. It was very focused on operational energy, energy use in a building, lights and heat and cooling. And so that really felt like the mechanical engineers territory. And I think as structural engineers, we sort of said, oh, okay, well, some of our stuff is recycled, but there really wasn't much kind of depth to it. But now I would say where we are today, thinking about embodied carbon is where we were maybe 10 years ago, thinking about operational carbon, right? That it's the whole picture. If you take the broader view, the whole life cycle view, right? That it's not just about what you emit as the building is operated, but what went into the materials that you're using to build the building, kind of understanding that that's also quite a big footprint. And actually that sort of portion of the building sector's carbon footprint is getting, relatively speaking, bigger all the time because we've gotten pretty good at reducing operational emissions. So this embodied carbon piece, I think now is really capturing a lot of attention in a way, like I said, that we, kind of where we were 10 years ago with operational carbon. And so there's a lot of discussion about different materials, and there's a lot of effort going into trying to make all of our structural materials more sustainable. The production processes for steel and trying to figure out things like carbon capture in concrete. Concrete has a particularly large footprint. So, and so you'll sometimes see the different sort of industries a little bit squabbling with each other about, sort of everyone's accusing each other of greenwashing and all these things. But really, to me, when it comes down to it, timber is the only structural material that we can regrow, right? We don't mine it. We don't take it out of the earth, right? We can replenish it. And so even though, yes, there are subtleties that we can and should investigate and argue about what, how do we really do the accounting when we do these things? And when we do a life cycle analysis, how do we do that accounting? That's important. We need to have all those discussions, and we need to be also looking at ways to make steel and concrete more sustainable. But to me, it just seems so plain that, as long as we are committed to, growing trees in a sustainable way and managing our forests in a healthy way, it kind of seems like a no-brainer, especially given with the relatively small piece of the market that mass timber has. There's such an opportunity to just immediately drastically cut our embodied carbon footprint without needing to rely on technologies that haven't been invented yet, which maybe they will be, but at the moment, sort of this to me feels really like the best way to go.
Yeah, and I think like you kind of said it, it's kind of no-brainer, but I know there's subtleties, like you said, like maybe there's some inefficiencies during the making of the wood process, but like you said too, they can, if we manage to maintain the the forest and things like that to make it more sustainable, I think that seems maybe more straightforward than maybe with steel or concrete. But I think the important thing is all of the industries, all the materials are trying to find ways to make their processes more sustainable. So I think as an industry, we're going in the right direction, since it is becoming more and more important to us, but also our clients and the architects. It's definitely something that's growing, and we should do our part as the structural engineers. This isn't something that we should just architect or
Right.
someone else do it. So
Right.
I think that's uh, all the industries are going together in the right way. I did want to switch gears to some of the building codes. I know you kind of mentioned this before earlier in the podcast. Yeah, real buildings. Yeah, you can't make real buildings with wood, with timber. But with these code changes, maybe you can get these super tall buildings, or maybe just tall buildings. I know that that's even being built around the world. So in the let me look at my notes here. The 2015 IBC, it's possible to build timber frame structures up to 6 floors and 85 feet tall. But there are several exceptions to this rule, and depending on the city and the provinces or states, that may not be as stringent as this. So, how tall can uh, we go with mass timber, and should we go tall with mass timber?
Yeah, so I always find this a very interesting topic, both can and should. So starting with the can, so how tall can we go? So different codes across the globe address the height question differently. In the US, there was a very big change, as you mentioned, in 2015, and then again also actually in the 2018 IBC, which is the basis sort of model code for just about every jurisdiction in the US. 6 stories and 85 feet. But in the 2021 version of the IBC, which a few of the states are now on, we can go actually up to 18 stories in timber. And so that was a huge leap. I had the good fortune and experience to serve on one of the working groups, the structural working group of the ICC ad hoc committee that created and implemented this change to the code. So this was, you rarely see changes this major from just in one code cycle. It usually comes very, very sort of gradually and incrementally. So this was a really big step in the code that lets us go, like I said, up to 18 stories. In the US, the taller you go, the less timber you're allowed to leave exposed. That has to do with some of the fire testing that was done. It's mainly related to fire safety, but even, you know, seeing in the 2024 version of the code, for example, you see like more timber will be able to be exposed. So we're constantly sort of, the codes are trying to keep up with the state of our knowledge. That's always tough because the code process is, you know, intentionally so kind of a slow, deliberative one. So, you know, the code always wants to sort of really be, you want to be really sure of something before we sort of put it in the prescriptive code. And so there's been a lot of development, right? So now we can go quite a lot taller. And then there are, as you mentioned, projects that go beyond those code limits. You know, there's a 25-story building in Milwaukee that's 19 stories of timber over 6 stories of concrete. There's a fairly tall 18-story all timber building in Norway, among some other tall timber buildings in Europe. They're in construction on a mass timber hybrid tower in Sydney that's going to be, I believe, 39 stories. So you're starting to see buildings sort of push into that 20, 30, 40 story range. I think, so again, the codes will continue to evolve. It's a little bit of a challenge, you know, when you think of, you know, mass timber is really having its growth spurt, I almost want to say, if you will, of, you know, people really starting to push the limits. And we're doing that at a time where, in a sense, it's more difficult than ever because the codes are more, I don't know if restrictive is the right word or complete, but, you know, where we used to have, you know, when they were figuring out how to build, you know, really large sort of masonry cathedrals, right? There were basically almost no building codes back then. That was trial and error. And then when we were figuring out how to build steel skyscrapers, right, there were codes, but, you know, the code book was, you know, maybe half an inch thick. And now you've got 8 volumes that are 6 inches thick. So it's not a bad thing, right? This is all in the name of public safety, so it's a good thing. But it is more difficult, right? There's just more sort of a little bit more restriction. So codes are coming along, I would say, about as fast as we could expect them to in the world that we live in today. In terms of, again, on the question of can we, I think on the engineering side, going tall in timber because it's such a lightweight material, solving the wind-induced vibration problem is one that will get a lot of focus. I think this is, pretty solvable. We've just got to figure out sensible ways of sort of damping the structure. So, where you might see, for example, a tuned mass damper in a concrete super tall, you might see those things in a mass timber, just regular tall rather than super tall, just because they have more of a tendency to vibrate. And then, there is, I think when you start getting again into that, tall is always a relative term, but once you start getting into the 30, 40 plus stories, the column sizes, if you're just trying to design all in timber, get a little bit impractical. Like you just need such a big column that it's not going to make too much sense. So I think, as we push taller, you're going to certainly see hybrid structures leading the way there. But to me, the more interesting question is not can we, because the answer is almost always we can, at least from an engineering perspective. And I think that's part of human nature, right? Of just figuring out, something that's never been done before, taller. That's, it's a bit human nature, but, should we? And there's a lot of differences of opinion on this. I mean, my personal feeling is that, I'm not sure that in an ideal world, like, do we need super tall buildings? I sometimes find them a little bit silly almost. I just think they're the product of sometimes some combination of sort of ego and maybe like weird zoning restrictions that make it such that we, in order for a project to make sense in certain parts of our cities, like the only way the project makes sense is if it's a very tall project. But I think what's interesting is if you compare, say, the US to a lot of European cities, like take Paris, for example, right? So, the central part of Paris is every bit as dense as Manhattan, but they don't really need such tall buildings. So there's this idea that you start to hear more about what sometimes is referred to as the missing middle, right? So we have a lot of, out in the suburbs, a lot of single family detached homes. And then in the urban cores, we have these like really super tall towers, and we don't always have a lot in between, but it's that, I think there's some really interesting things to be done in that sort of middle zone where you have density. I've also heard it sometimes called gentle density, which I like, because I think in terms of sustainability and the way that we build, and this is now sort of at an urban planning level, this is not just at the building level, but thinking about how do we have, a reasonable level of density so that we're not just sort of sprawling out anymore, but keeping it kind of at a human scale. And so I personally would, if you offered me, like you can design 100-story timber building or 10-story timber buildings, like I would take the 10 stories any day, because I think, although I can see the attraction from an engineering and a problem solving perspective of trying to do these like very, very tall buildings, again, it's sort of human nature. Like we just love a challenge. But I'm just not so sure that those, although they get a lot of eyeballs, so to speak, right? They get a lot of press and maybe they capture imaginations and maybe they do help us come up with new innovations that can be applied to other buildings as well. I just think there's a lot of important work to do in that missing middle, right? Of trying to do that, these sort of buildings that are in that mid-rise range, which are really interesting to me. So like doing those buildings, as many of them as possible, as well as possible, and make it sort of replicable, right? Because a lot of these super talls, like those are the most bespoke of all projects. Like you do them once and you won't ever do anything like that quite the same again. So to me, this is kind of a long rambling answer to, we will continue to push taller and taller just because that's what humans do. But to me, I would love to see lots of our brain power also going towards, like I said, doing really high quality mid-rise buildings all over the place.
Yeah, thanks for that. That was a interesting perspective. I think for me, I haven't really thought about in terms of the urban planning phase of that. Yeah, super talls, they may not be the most efficient since you're kind of funneling everybody into that super tall building. And Yeah, it's something I haven't thought about, but that's like
Yeah,
an
they
interesting
tend to be
perspective.
energy hogs, right? Tons of embodied carbon in those structures for sure. So you start to think, when you start to think with that sustainability hat on, again, you sort of think, well, yes, density in general is a good thing, but sometimes you wonder, like, if we've taken it too far.
Yeah, maybe those 10-story buildings, copy and paste, maybe even from an engineering perspective, that might be more efficient than I'm sure those mega projects. There's a lot of complication that goes on
Yeah,
with
yeah. And the
those.
mega projects are never going away, right?
Yeah.
Those are still going to happen no matter what I think. So, like I said, I think not forgetting about that missing middle is part of our challenge ahead.
I remember in college, like it seemed like there was like just like those students are like, I can't wait to get out and design sky rises, like that was like their goal. And then other people were like different direction. But I totally agree with you with that missing middle. And I think the other thing from that is like from like the personal experience when you walk into those buildings that are more of that mid-level. I feel like the experience can be, I don't want to like neglect all buildings that are tall, but I feel like that experience can be so much more enriching because it's like it just feels like it's at a scale that's more inviting.
Yeah, it's at a human scale, right? It's sort of, I feel the same. And like I said, I know that's
Totally.
um, a very personal preference, but for me, for sure, yeah, that human scale is kind of is important.
Same.
And I think, so getting more of those buildings would be more fun for me. And like I said, because timber is evolving, even when you say, like you said, I'm sort of implying this cut and paste approach, but it still isn't a cut and paste approach because timber is evolving so quickly that even if it's only a 10-story building, right, there's plenty of innovation to be had and cool things to do, even if it's not super tall.
Yeah. Just curious, in terms of like height, what is the tallest timber design that you've been involved in?
So the firm that I was at previously were the engineers for Brock Commons, which is 18 stories. And so that was actually one of the buildings that really helped push through the code changes that allows 18 stories in the US. Really, that building was sort of the model for what's now called type 4A construction in the IBC, which lets you go up to 18 stories. And so that's a very cool project, and it was nice to work at that firm and sort of see that go up. But right now, most of the things I'm working on are more in that sort of mid-rise, the mid-rise range, and I'm very happy there. I'm okay with that.
Cool. Okay, what about when you have clients that are considering using mass timber in their projects? What are some of the things that you tell them that they should consider if they are to go that route with the mass timber?
Yeah, one of the things that's really interesting, I think, because mass timber structures are very, sometimes I describe it as sort of structure forward or structure driven, in part because the structural system is relatively unique, in part because a lot of times part of the impetus of doing mass timber is beautiful and you want to leave it exposed. And so the structure also is the architecture in a lot of ways. And so you sort of find yourself, again, like being drawn into roles or conversations that maybe you don't get involved in when you're doing steel and concrete buildings. And those are the conversations that the architect maybe is having with the client. But I find that I'm having lots of conversations of trying to, a lot of times, frankly, educate clients about what this really is, because it's become a bit of the shiny new thing. People are hearing about it. They think it sounds cool. They think it looks cool because it does. It's gorgeous. But we're an industry where everybody wants to just keep recycling. They just want to like rinse and repeat, right? They want to do the last thing they did. We're not. There's a lot of inertia. Everybody wants someone else to sort of do the new thing. They want to, and they'll be first to be second. I usually joke, right, because nobody wants to be the guinea pig. And so because it is so different, and I have found that you'll find a lot of clients that since they don't know what they're getting into, like you'll sort of waste some time because they aren't serious about it. And what I mean by that is just you've got to figure out first sort of two things. You got to figure out like what is their motivation? Like why are they interested in mass timber? Is it an aesthetics thing? Is it a sustainability thing? Is it a they're just interested in prefabrication and offsite construction? Do they want to try to, cut down on the construction schedule? There's a whole bunch of reasons that they might be interested in it. So what are those reasons? And then also, what do they know, right? There's such a huge range of knowledge, like to clients that are completely new to it, to clients that have maybe done some of these projects before. And so if you really have to, I think, to have a successful collaboration with your client, really understand both of those things, like what is motivating them and what do they know? And that way you can sort of use that knowledge to steer the conversation a bit, like how, because sometimes I think people are under the impression, especially if they're new to it, that it's like they can have their cake and eat it too. It's like, it's going to be all the things. It's going to be more beautiful. It's going to be faster. It's going to be cheaper. It's going to be right. And generally speaking, you sometimes have to, like, there's 3 things and you can pick 2. You know what I mean? I joke a lot. I have this, sometimes I've seen this sign like in shops and stuff, and they'll say, we offer 3 kinds of service: good, fast, cheap, but you can pick only 2. So, and I think that's true. Like, I almost want to put that on all of our proposals, right? It's true of professional services as well. You know what I mean? So again, kind of understanding, that's what I mean about understanding, like, what is motivating them, so that you can really try to focus most on those things, right? Because a client who's most interested in, let's say, building a high-end residential where the timber is going to be exposed and that's going to be a differentiator, and aesthetics are a huge driver, is going to be very different than a client who is in it for sustainability reasons versus client who heard that these buildings go up really fast, and wants to. So really asking questions that often we leave to the other members of the design team. Like, it's really important as the structural engineer to understand that. And then, like I said, kind of understanding what they know already, so that you can kind of figure out what you need to teach them to get yourself to kind of a successful place. Because a lot of times, I mean, I've been on, unfortunately, umpteen projects where there's an expression of interest in doing mass timber. And so you kind of do like maybe a schematic level design, and it goes for pricing. And then, it comes back, if it comes back a little more expensive, maybe it gets, it sort of dies on the vine, or if you really want to give the project the best chance of actually being built in mass timber, it's, I think, really about kind of understanding the client and their drivers as much as possible, so that you can really try to focus on those things.
Yeah, that's perfect. And depending upon what those answers are when you're discussing it with them, you can steer them in a certain direction.
And Tanya, to end off here, I know you've had a very successful career. You're vice president at Entuitive. You've got your master's. You're involved, and I believe on the board on Woodworks and some of the advisory committees, and worked with multiple companies, design companies, fabricators. Do you have any final advice that you can give to structural engineers that are looking for success in their careers?
Yeah, I would say, especially to students, and maybe even students who haven't decided what they're going to study in college, or to engineers who are young and early in their careers. This is a very interesting and rewarding profession that has a lot of potential to do good in the world, I think, especially in the face of the climate crisis. I would also say, though, that sometimes as a profession, we get a little bit stuck in old ways of doing things. There's a lot of inertia, and that can be a bit dangerous. So if this profession is going to thrive rather than just survive, and if we want to attract and retain talented people, I think we can't be afraid of change. We have to really embrace it. And, through my career, what I've seen is that it's almost always and very reliably the younger generation that has the energy and the courage that I think we need. But we also sometimes tell people, no, you got to put in your time and be patient. And then once you've been doing this for 20 or 30 years, then we'll put you in a position of influence. And I think that's a really big mistake, actually. I think my advice, especially for young folks, is to speak up, both within your firm when you start working, and then within the industry in whatever ways you can. I think your ideas are really important, and they're going to help us evolve into something better than we are today. And so I look forward to where that generation is going to take us.
That was great advice. Yeah, I agree with that. I think it's a lot of the younger folks, they think it is maybe, yeah, they don't know enough. Sure, you might not know enough if you're like a year or two in, but I think your perspectives are what make it valuable, that new
Yes.
perspective versus
Yeah,
someone that's been
completely.
doing it for 20
Hmm.
years.
Yeah, it's like finding that balance of, right, the sort of knowledge and wisdom that comes with the gray hair, but the energy and the ideas of young people. And so I always get a little bit nervous if I see, um, really creative, talented young people who get sort of stuck in a corner for a while, just doing whatever it is, finite element models or checking shop drawings or all those things need to get done, right? And part of the way I got to where I am and know what I know was by building finite element models and checking shop drawings. But that doesn't mean that we shouldn't let the folks doing that really sort of show us the way in terms of where the profession needs to go. And, I think there's sometimes this, we sort of link your technical knowledge and experience with kind of your leadership abilities. And they're actually, in a lot of ways, completely decoupled, I think, in my mind. You can be really good at one and not at the other. And vice versa. So I think as a profession, we could do a lot better at listening to our young folks.
Yeah,
Definitely.
thanks so much, Tanya.
Yeah, thank you, Tanya. It was great
Thank you.
to talk with you.
Thank you so much for having me. It was really fun.
I hope you enjoyed the episode today. We'd love to hear your feedback, comments, and or questions. To leave them, please visit structuralengineeringchannel.com. There you will find a summary of the key points discussed in today's episode, which is episode number 96, as well as links to any of the resources or websites mentioned during the episode. Don't forget to subscribe to Apple Podcasts, Spotify, or wherever you listen to your podcasts. Until next time, we wish you the best in your structural engineering endeavors.